Chapter 3, Section 10 is about relations. A relation is simply just a set of ordered pairs, and the set of first coordinates, or the x values of these ordered pairs, is called the domain of the relation. If we look at the set of the second coordinates, or the y coordinates, that would be considered the range of the relation. We can use a mapping diagram to show the correspondence between the domain and the range. So as we look at this particular situation, we see that we have the domain, the numbers 1, 2, and 3. We have the range, the numbers 0, 1, 2, 3, and 4. In the mapping diagram, we draw lines to show correspondence. So in the domain, the point 1 is matched with 0 in the range, and it's also matched with 2 in the range. So that means we have the point 1, 0 and the point 1, 2 as our set of ordered pairs. We also have 2 in the domain mapped to 1 in the range and 3 in the range, so we also have the ordered pairs 2, 1 and 2, 3. And then 3 is mapped with 2 in the range, and 3 in the domain is also mapped with 4 in the range, so we have the ordered pairs 3, 2 and 3, 4 as well. So another way to describe this particular relation is by listing all the ordered pairs in the set. As we said, we've got the 1, 0. We have 1, 2, we have the ordered pair 2, 1, we have the ordered pair 2, 3, we have the ordered pair 3, 2, and we have our last ordered pair 3, 4. So that's the set of ordered pairs known as our relation. Alright, we can also represent these not only by the mapping or by listing, but by graphing as well. So if we take a look at a graph and take those exact same points, let's see if we can fit them all here in the screen. So there's the point 1, 0, the point 1, 2, there's the point 2, 1, the point 2, 3, the point 3, 2, and the point 3, 4. So in this little area, we've shown this relation 3 different ways. In our mapping, listing the set of ordered pairs, and drawing them all visually on the graph. We have a stronger term than relation. Relation is just a set of any ordered pairs, but now we take a function, which is a relation. So a function is a set of ordered pairs, but there's an extra condition we have to meet. Every member of the domain is matched with only one and uniquely one member of the range. Another way to say that is the function is a relation which the ordered pairs have different first coordinates or different x values. So a function is a relation where there is no repetition of x values, and the official name for that is the abscissas. So all we want to do is we want to take a look and see if this particular set of ordered pairs is only a relation, or whether it's the stronger term, it's also a function. So let's compare all the x values. We have 9, -5, 2, 3. And we don't see any repetition of x values. Each x value is different from each other one in each ordered pair. So yes, in that particular case, that is a function. And there's another way to test to see if a relation is a function, and that's when you have its graph. You can think of and visualize every possible conceivable vertical line intersecting that graph. If that vertical line intersects the graph at one point, it's a function. If it's more than one point, it's not a function. So let's look at the next particular graph and see what we think. So think of every vertical line. Let's just take the edge of this tool palette and move it from left to right across the graph. And as we do, we see in the little ghost shadow that every conceivable vertical line only hits the graph at one particular place. And since that's true, then yes, this particular graph represents a function. It passes the vertical line test. Let's look at another graph and see if that passes the vertical line test as well. So here's this particular graph, and we can see certainly if we take the right edge of this Photoshop tool palette, there's a vertical line that does not hit the graph at all. Here's a vertical line that hits the graph at one point, the vertex. But if you can find a vertical line that hits the graph at more than one point, then we can safely say that no, it is not a function. And if it's not a function, therefore it's a relation. Alright, let's look at this set of ordered pairs. And first of all, we're going to give the domain. those are the x values. We're going to give the range, those are the y values. And then we'll decide whether it's a function or not. And when we list these as domain and range, we'll put them in numerical order. So instead of 2, 4, 1, 3, 5, let's put them in numerical order 1, 2, 3, 4, 5. So the domain is the set of numbers 1, 2, 3, 4, 5. The range would be the y values then. Now 3, we'll come back to that in a second, but we've got 2, putting them in numerical order. 3 appears twice. You remember that in a set, you don't write it twice, you just write it once. So that's why it looks like there's 5 points for the domain, and it looks kind of like there's only 4 points for the range, but that's because we have the repetition of the 3. We also have the 4 and the 6 for the y values. Since there is repetition of y values, that's not of concern to us at this point, because what we need to do is look for repetition of x values. And since there is no repetition of x values, then this relation listed above, we can use a stronger terminology and say not only is it a relation, but it is a function as well, since there's no repetition of x values. So that's our definition of relation and function.